having a problem today getting this off the spatula. There we go. Sticking with the mineral oil. Maybe it'll break the beaker. Okay, there we go. What do you know about that reaction? Anything different about it? It's a little faster, right? Uh-oh, got on my finger, I don't want that. One more piece in. Oh, this might be too big. I'm always careful on this one because I think I told you last time I had a mishap on this one before, where I put too big of a piece in. I had a little mini explosion. Actually, it was a pretty big explosion. It went all the way to the document camera glass and I had to clean it up and it was a big mess. Okay. So similar reaction. The bubbles you've made here, perhaps you can see it moving out. There's hydrogen gas being given off here, right? What's going on here? Sodium metal is reacting with
Water
water
to make sodium
Produce
hydroxide
sodium hydroxide
and hydrogen.
and hydrogen gas. Now, the last time I showed this demonstration, the reason I showed it, is because I wanted to talk about the fact that elements in the same column, right, or group, have similar physical chemical properties. This is the reaction I showed. This is a reaction that all the alkali metals undergo. What's the reason it's pink again? Can you tell me why it's pink?
Is the hydroxyl
Because
group.
I have that sodium hydroxide base that's formed, and now I have a balanced equation. What's the charge of that cation? What's the one of this one?
-1.
Minus 1. So it's always a 1-to-1 ratio because the alkali metals are +1. Hydroxide is going to be -1, right? Okay, let me get this out of the way. Maybe I'll put it in the sink just to make sure I don't knock it over or something like that. Okay. So you should also be aware of and know the fact that the alkali metals do these. There's other reactions that alkali metals undergo, by the way. These two I want you to be familiar with. Of course, this one should be easier to remember because we've already seen it 2 times, right? Which is another reason I decided to show it again, even though we've seen it before. You can see how readily that reaction happens. Okay. One more type of element. One other element we're going to talk about that we've already talked about already, actually 2 different times, or 1 time here already in the alkali metal reactions. So when alkali metals react with halogens, we get formulas of Mx, +1, -1, right? For alkali halide, or alkali metal halide, excuse me. The halogens also undergo some reactions very readily. These are just a couple types. They undergo other ones as well. So the groups 7A nonmetals, which are the halogens, react readily with many metals, not just alkali metals. They react with alkali metals and other ones as well to produce metal halides, and with hydrogen to produce hydrogen halides. What does this mean? Now there's a mistake in the notes. I have a little note here. I was making these up. Remember that I told you there's a new edition of the book and I was making these up actually right before school started and I was like tired, I remember. So if you go in your notes, you'll notice that there's a mistake. I wrote this down wrong. So I don't know exactly what my mistake was. I already fixed it. So look to see what you have here in this box. I think I was missing the N here. Was I missing the N there? Okay, so put an N right there in your notes. No, I'm not missing the N right there. Okay, there's my missing the N. I knew I was missing one of those. That's where I'm missing the N, right? Was everything else the same on that one? Okay, so just forgot the N on that one. But then this one here, I want you to just cross out the reactions you have in your notes and just rewrite a new one, okay? The one I wrote is incorrect. I don't know what's happening there in my brain. So cross it out and I want you to write this one down instead. So I think so I'll just tell you a little bit of, so this, here I wrote here many metals, right? This is not all metals, but many types of metals. And the types of metals that the book doesn't tell you, and I'm going to tell you that this section is talking about, is going to be mostly transition metals, okay? So certain types of transition metals react with halogens by this general pattern. The metal plus the halogen, of course the halogens are all diatomic elements, right? To produce formulas like this, MXN. So if you have, if this number here is 2, you're going to have a 2 right here. If this number here is 3, you're going to have a 3 right here, okay? Here's an example. Chromium metal reacts with iodide to produce chromium 3 iodide. Why did I say chromium 3 iodide? What's the reason I said that? Because the chromium has a +3 charge, right? So I did a little crisscross thing in my brain and figured out that chromium is +3. Does that make sense what I'm saying?
Yeah.
And why did I say chromium 3, not just chromium iodide? Why did I say it was like I wrote Roman numeral 3 in parentheses?
Cause it's a transition
It's got
metal.
a transition metal, right? And that one I need to say what the charge is. So this is a reaction that happens with the transition metals that form +3 cations, which many of them do, by the way. So when those transition metals react with halogens, they will form +3 cations, and we get formulas like this. Anyway, so that's the general reaction for that, okay? And one more reaction I want you to know, or two more reactions I want you to know, be familiar with, which are less important than combustion reaction one, right? That's the most important of all these, is hydrogen and halogens reacting to form hydrogen halides. Like, for example, HCl, HBr, HI, right? How would you name HCl if it was in, so this HCl is a gas, actually, at room temperature and pressure. What happens if you bubble some HCl gas into water? What's that called again? Hydrogen chloride in the water is called hydrochloric acid, right? So hydrogen gas, halogen gases react readily to form hydrogen halides. Okay, last type of reaction. Halogens react with each other to do something called interhalogen compounds. If I mix together some fluorine and some iodine, I'm going to get some of this iodine monofluoride. Why am I saying iodine monofluoride for this one? What am I calling it that? What's that mono in there for?
To annotate that there's only one.
To annotate there's only one, because I'm using what kind of rules to name that one? The binary molecular compound rules that we talked about a while back now, right? That still follows us around the rest of the semester and year. Because iodine and fluorine are both nominals, aren't they? This is two types of nominals, so I'm just using my rules, right? First element, you don't use a mono prefix. Second element, you do if there's only one, right? So it's iodine monofluoride. So those are some basic reactions that the halogens and the alkali metals, and of course, well, that's too many things in the combustion reaction I want you to be familiar with at the end of chapter 4. Okay, any questions on those reactions before we move on to chapter 5? When did I make the due date for math chapter 4 mastering? I forget. Huh? Okay, still a ways away. Sunday night? I put it from the syllabus here. Yeah, still a ways away, so you still have quite a bit of time to get those finished, right? Usually like to make those up, quite a bit after we finish in class too, so you don't have to, well, not too stressful, but it's ideal if you're doing those along the way and not waiting to the last minute, right? Because usually there are how many hours of time for an average student, so. Okay, so chapter 5 has a number of topics in it, but the first topic we're going to talk about is about solution concentration. So the title is Introduction to Solutions and Aqueous Reactions. So the first part we're going to talk about is a concentration unit called molarity. Okay? First of all, what is solution concentration? It's the amount of a solute, which is a substance in a solution that's present in lower amount. So it's the amount of a solute in a solution is given by its concentration. Now there are many different units of concentration we can use. And chemists use more things than just molarity, but molarity is a very important one. We've already used molarity in lab. Remember the limiting reactant lab? We did lab, it's already 2 weeks ago already, it's almost, isn't it? We had a lab last week. Remember how to use 1.0 capital M molar HCl solution? Okay, and what that meant, so molarity, capital M, that's a symbol for molarity, is moles of solute per liter of solution. When we had a 1 molar HCl solution, it means we had 1 mole of hydrochloric acid per liter of the whole entire solution. That's what that meant. Okay. Oh boy, I have a problem down here right below. Beginning of class, I passed something out to you. What did I pass out? You all have now. Exactly. So what do you think we might be doing next? Okay, so the title of that activity is what?
Molarity.
Molarity. Okay, so they can get back in your groups. Ideally the same ones you had before in the last 2 or 3 times we've had groups, right? And we're going to work on this molarity activity now for a little bit of time.